Today we will be seeing the single component analysis method, that is the calibration curve method using UV visible spectrophotometer. The reference for this is Practical Pharmaceutical Chemistry by Beckett and Steinlich. The drug today used is paracetamol, which has analgesic, anti-inflammatory and antipyretic action. We intend to develop a simple analytical method for analysis of different drugs. The preparation requires dissolving 100 mg of paracetamol in 0.1 normal NaOH and dilute up to 100 ml using a volumetric. From this we take 1 ml and dilute up to 10 ml, which gives us a 100 microgram per ml solution, which we will use as a working solution. Using the working solution, we will prepare concentrations of 2, 4, 6, 8 and 10 ppm by diluting 0.2 ml up to 10 ml, 0.4 to 10, 0.6 to 10, 0.8 to 10 and 1 to 10 ml using 0.1 normal NaOH. The steps to be followed: first, do entry in logbook. Then second, open the lid of the UV and remove the desiccant. Switch on the instrument and wait for its initiation. Now we will open the UV software. It is UV Probe 2.34. So here we see the connect button. We will click on the connect button. The instrument is connected. Now we will start taking the baseline reading. Now we will check the baseline. For the purpose of baseline, we select the wavelength 400 to 200 nanometer. For this purpose, we have kept blank or 0.1 normal NaOH solution in both the test and the reference cuvette. We can view the slewing process, that is the baseline check, in the left corner. At the bottom you can see the wavelength is changing. Now it is showing 0.001 absorbance. We will do auto 0 so that it balances the transmittance. Next we will have to do the sample analysis. So we will place the sample of paracetamol 2 ppm in the sample cuvette and start recording the spectra. Once we have placed the sample, we will press start and the scanning will begin. You can see in the left hand side corner the absorbance at the changing wavelength. Here we can see the increase in absorbance. Till this point there was no absorbance, and now a Gaussian curve will be formed indicating the lambda max. After completion, we save and then we go to the operations menu and pick peak. Here it will record the lambda max and lambda minimum. Here we can see 256 is the lambda max for paracetamol. The absorbance is 0.286. After this, we can note the absorbance at specific wavelength by go to wavelength. Mention the wavelength we want, and at the left hand side corner we will get the absorbance for the same. This is for 2 ppm solution. For 4 ppm, 6 ppm, 8 ppm, 10 ppm. We will note the absorbance in a table and plot the same on a graph paper. This is plotted. We can draw a line using minimum 3 points. We start from the origin. We can extrapolate to some degree. Now we will record the unknown and plot it on the graph. The unknown 0.750. We will plot it on the graph. From this we can find out the concentration of the unknown, which is 5.6 approximately. Using a graph paper will give you the exact value. Note the result. The concentration of the test sample was found to be 5.6 ppm.